This pile load test is mandatory. Mandatory means it is compulsory to carry out the pile load test. Some percentage is given. There are two types of tests. One is initial pile load test and another is working pile load test. So this initial pile means this pile will be cast separately, it is not part of the structure. You cast the pile, do the test and forget about the pile, it will not be used for a part of the construction. Working pile load test means you will do the test and continue to use the pile for further improvement. What you are seeing here is called as a cantilage, there are some eye sections. Your test pile is somewhere in the middle of this, so you are loading it by a jack using sandbags for loads and then use other piles. There are maybe 4 more piles here at 4 corners that will give the reaction. So this can be performed either on a working pile which forms the foundation of the structure or on a test pile. Test pile is the initial load test pile. This test load is applied with the help of calibrated jack. The jack will be having a load corresponding to the pressure. This has to be placed over a rigid circular or square plate. This plate is placed on top of the pile and this pile should be projecting above the ground level. So you have the pile which is projecting above the ground level, put a plate, then you put a jack, then apply the load. And when you apply the load, you have to apply in equal increments of about 1/5 of the estimate allowable load. Suppose the estimated load is about 1000 tons, increment as 200, 400, 600, 800 and 1000. Sometimes they use 1/10, 100, 200, 300 like that. The point here is you apply a load of 100 tons, do not take the reading and go to next increment, you keep it for some time for it to stabilize. So you have to load it then unload it also. What we record is the load that is from the jack, then also you have to record the settlements. Usually we use 3 dial gauges and the sensitivity is 0.02 mm, that means it can measure a minimum of 0.02 mm and these 3 gauges should be arranged symmetrically over the test plate and fixed to an independent datum bar. So there is an independent datum bar with which you fix the dial gauges so that when the pile is going down you can measure the settlement of the pile. The initial test piles you load until the ultimate load is reached. Sometimes you may not be able to reach the ultimate load. In such a case we apply the load up to 2.5 times the estimated allowable load. Suppose 400 tons is the capacity of the pile you need, then you load it up to 1000 tons, 400 into 2.5, or we have to apply a load which causes a settlement equal to 1/10 of the pile diameter. Suppose pile diameter is 1200 millimeters, the settlement you have to measure up to 120 millimeters, whichever occurs earlier. Suppose 120 millimeter occurs earlier, suppose let us say 800 tons, you have to stop at that point of time. So you have to plot the load settlement curve. The ultimate load is indicated by load settlement curve approaching vertical. You will get a load settlement curve like this. So when it becomes vertical, so this settlement and this load is the test load, this is your settlement. There are other criteria also. 2/3 of the final load which causes a settlement of 12 millimeter, or 2/3 of the final load which causes a net settlement of 6 mm. So this is some advanced options that I am not teaching now. So this is your load test arrangement. Details are given here. This is called as a cartilage. This is the dead load. Dead load means we can use anything. Normally they use the sandbags, bags filled with sand. These are the points which supports the cartilage. There is a truss which is connecting them. This is your pile. We are talking about a plate. The plate will be somewhere here. This is your jack. This is the piston of the jack. Suppose you want to make the deck slab, you make the deck slab but leave a opening here so that the jack will go up and down, and this frame is attached to this, and you can measure the, I am sorry, this frame is not attached to this, this is connected only these two piles. You have 2 dial gauges marked here to the test pile, then this is connected to the rigid base, that is the slab permanent benchmark through which you can measure the settlement. So this test pile is done in offshore condition where we have a sea water for about 11 meter deep. Below this is the water level. So you raise the pile above the water level and put the cartilage and load it. Now I will explain the test procedure. Test procedure, what you do is, first you cast, there may be 4 piles at 4 corners, in the middle you will have the test pile. On the 4 corners you put some pad for supporting the reaction, put some steel girders like this, these are the eye sections what you are seeing, these are the eye section the other direction, there is one more eye section here on top of it, this is called as a grillage foundation. In this grillage foundation for 1000 tons you put the sandbags. Where the load will go? Where will the load go? Yeah, it will go to the 4 corner piles. Then what you do is you apply the jack, then the piston will go and touch it, then you apply 100 tons, this total weight is 1000 tons, you apply 100 tons here. What will be the load coming onto this? 100 tons. What will be the load going onto the 4 corners? What? 1000 minus 100, 900 tons will go. It's clear, no? Initially all the load when the jack is not touching will go to the 4 corner piles. Subsequently you apply the load, when you apply 100 tons here, 100 tons will go here, reaction, the balance 900 will be shared here, then 200, 300 like this. Finally all the 1000 tons will go here, and if the load is not 1000 tons, the whole cartilage will fall down. Okay, normally if you want to test for 1000 tons we put 20% extra, 1200 tons, so that your 1000 tons is applied here and 200 tons are going as a reaction. It is a time consuming process, but it is the most commonly used method. This shows the photograph where you are seeing these 2 frames attached to some benchmark, then there is one plate which is connected to this test pile where you measure the deflection. This is the jack, the piston, then you have this grillage with an eye section with a web stiffener so that the load is transferred. It is purely a temporary arrangement, but this has to be done. Minimum 1 initial load and 3 working pile load is required to be done. So you can see the grillage here, you can see the sandbags inside. If you want, you can full loose sand also, no problem. Suppose you want to apply 1000 tons and you are stacking for about 5 tons, 5 meters, then what we need is 1000 by 5, that is 200 square meter. 200 means it will be about 14 meter by 15 meter, you have to stack the load. Any doubts in this? See, this method is very cumbersome, it is very difficult and all those things. So yesterday we have seen some integrity test, it is called as low strain integrity test. We also have another test called as high strain integrity test. It is also called as dynamic load test. So what you have seen in the earlier presentation is static pile load test. You apply the static load, then apply it. So in a dynamic pile load test or in high strain integrity test, you have to use one hammer. This hammer is about 1% of the test load capacity. If it is 400 tons, you have to use a 4-ton hammer, and there is a drop, it may vary from 1.5 meter to 3 meters. It's clear now. The low strain integrity test which we discussed in the last class, you use a hammer and tap it. Here what you do is you take a, that is a handheld hammer. Here it is a heavy hammer which is 4 ton. You cannot lift 4 ton and all. You need a separate rig to test it, to lower it with a drop of 1.5 to 3 meter. Then measure the record. Based on the record, you can get the pile load capacity, pile capacity. Okay. So this is the static pile load test. The second one. First one is static, using this cartilage things. Then in the static cartilage also we have two types. One type is to measure only settlement, another type you will measure the skin friction and end bearing. See, what do we do in this case? So what we do is we have the pile, the bottom of the pile we put a pressure pad, along with the reinforcements you attach load cells. Attach load cells, then you apply the load. So earlier we were measuring only the settlement, now you measure the load in the load cell as well as the pressure pad. So suppose this is your soil level, there is two methods by which the load is transferred. One of the method is by skin friction, which will act on the side, another one is the end bearing that will take place on the bottom. Suppose you apply 100 tons load, let us assume that you apply 100 tons, then this may take 30, this may take 25, and is 25. What I am telling is out of 100 tons this will be 25 plus 25 50 plus 30 80 plus 20 100 tons will go. But suppose this goes to 1000 tons, let us say at the end it goes to 1000 tons, this may go to 50, this may go to 40, this may go to 60, go to 100, go to 200, balance will go 300, 360, 400, 450, balance will go to 550 tons. So depending on the layer, the distribution I have randomly placed, the distribution of the load taken by skin friction depends on the strength of each layer. But when you apply 100 tons, there may not be any end bearing going to the bottom of the pile, because the soil itself will take the pressure. Then you can also do the test using what is known as anchors, we call as a rock anchor. This test is most commonly used for marine structures where rock is available. So in this method what we do is, so we have the water level here, we have the this is your seabed level. So in this particular method what we will do is, we will have a hole which will be made inside. Through this hole we will be inserting one anchor . The anchor will start from put this like this, suppose this layer is a rock, let us say. So this go like this, then we will penetrate through the rock, there will not be any tube, and then we will be grouting this portion. So this is grouting, this is your anchor, this is your hole. So here we will place one jack, there will be a jack which will be a hollow jack, it will have an opening here through which you can take the anchor, and we will have the piston going there, piston also will have a hole, and we will have the plate. So this anchor will be connected to the plate like this, bolt and nut arrangement. So using the jack you just apply the load. What you are trying to do is, you are trying to pull the anchor, right. When you want to pull something, there should be a reaction, that reaction will go to the pile, right. This anchor should be of having sufficient capacity. Only if rock is available we can do this method. This is another most commonly used method. So we have three methods, one is using a static pile load test, there we have two variations of measurement, one is settlement, another is skin friction and end bearing. The second one is high strain integrity test, which called as a dynamic pile load test, where you have to use the hammer which has a capacity of 1% of the test load that is to be done. Then we need some anchors if rock is available and do the test, something like this. So another important aspect is this initial pile load test. Suppose there are about 300 piles you have to do. It is preferable that initial pile load test is done before starting the 300 piles. You cast it separately, do the test separately and then do it. This working pile you should not complete all the 100 piles. Suppose you have to do 3 working pile, after 100 piles you do first test, after another 100 to 200 when you do, you test one more pile, 200 to 300, test one more pile. Do not do it after everything is over. They have done for Perambur flyover and they find lot of problem. After completing all the piles you cannot do. So you have to do the initial pile load test. Initial means before driving any working pile you have to do the initial pile load test. Then this low strain integrity test, this people say 50% of the piles, some people say 100%, that means about 150 pile you have to do the low strain integrity test. For the other thing you have to do, some people say 100%. The cost is not very high. The low strain integrity test, if you are doing in large number, this will cost only about 1500. This high strain may cost about rupees 3 to 5 lakhs, 3 lakhs only, 3 lakhs. This static pile load test is very expensive, it may cost as much as 30 lakhs. This rock anchor is a little bit less, maybe 15 lakhs you will be able to do. It depends on the load, type of soil and things like that. When you unload, this curve will go something like this. At 0 load you may not have 0 displacement, this is 0, let us say this is your 1000 tons, let us say this is your 120 millimeters. Giving the limit case, suppose the diameter of the pile is 1.2 meter, 1% of that, 10% of that is 120 millimeter. So this is what is called as the plastic settlement. This initial pile load test when you do, for doing this type of test you will go to the seabed. Suppose the water depth is about 15 meters, you have to have a gantry to do all these things. So initial test pile in exact condition cannot be done. So what they do is the initial test pile, how to do it in the ground, ground means land. See what they do is, there you will have the ground level here, no water here, then you drive one casing pipe. This casing pipe is larger diameter than your test pile. Let us assume this diameter is about 1500 mm. Then you erect your main pile, diameter is 1200 millimeter. Then you remove the soil to this level. Suppose this freestanding length is 15 meter, you remove the soil up to 15 meter. If you want to pour water, you can pour water also. You do the test, because you want to simulate similar condition, provided at the ground as well as at the offshore location the soil properties are same. We do not want the skin friction to go into this area, that is why we do this. So this is the 3 methods that is most commonly used for pile load test. So, we will discuss about this ground improvement in the next class, but this figure you please understand. What is given is percentage of passing through the sieve. There are two methods that are given, vibro replacement and vibro compaction. This will study in the next class. What is given in this x axis bottom is the grain size. Grain size means this particle size of the material. So, this particle size is 6 millimeters, this is 20 millimeters, this is 60 millimeters. Here the particle size is 0.002 millimeters, here it will be less than 0.002. If it is less than 0.002, then you will have a clay layer. The particle size is between 0.002 to about 0.02, then it is called as silt. It is bigger up to 0.4 mm, it is called as sand. Then I think they have classified up to this, maybe 1 millimeter they have called it as a sand. Beyond that it is called as a gravel, then more than 40 mm they call it as a sand, a stone. It is not very strict, these boundaries can change. So, in principle the smallest size is clay, the biggest size is stone. So, we have sand, bigger than about a millimeter is gravel, and less than about 0.02 mm is the silt. So, if you want to improve the ground, the method will be different for different types of soil layers. It is what is given here. So, here it is the ulta, this side is a smaller size clay, this side is silt and this side is sand. If you have stone and all, you do not need any compaction, any ground improvement. So, if it is any other type of soil, you have to do ground improvement. These are the various methods: vibro compaction, blasting, chemical grouting, compaction grouting, dynamic deep compaction, soil mixing, jet grouting. Jet grouting can be adopted for any type of soil, whereas vibro compaction and blasting generally is recommended for only sand, not for silt and clay. For clay generally soil mixing is used. So, these are the method by which you improve the ground. Why I am discussing the ground improvement is, suppose you have a very poor soil, if you want to transfer the load without improving the soil only by piles, the cost of the project is about 300 crores. Suppose you do ground improvement, then you install the pile, then you do the construction, the cost can come down to even 100 crores. Is it clear? You cannot simply go in for structural piles for the test, for taking the load. The soil is very bad, it is preferable to do all these things. But another important method that is used apart from this or in combination with this is what is called as preloading. The time consuming method. In this method what we do is, you go to the place, just like cartilage, you stack 6 meter height of soil, leave it for 1 year, then remove the soil. Since you have loaded the ground with the 6 meter of height, that is about maybe 10 tons per meter square load, it is kept for a longer time. The settlement what has to take place would have already taken place. See, the pile load test, it is not the load, this is the final thing which you should remember. It is not the load what the pile can carry, it is the load which it can carry with permissible settlement. Settlement, we have two types of settlements, one is called as a permanent settlement, another is called as a differential settlement. So, this load test, what we want to find out is the settlement. Settlement means how much the pile goes down. So, we have two types of settlement, one is a permanent settlement, and another is differential settlement, or we can call permanent or total settlement also. Differential means when you have two piles at these two ends, this pile is settling more and this pile is settling less, the difference between them, that is very critical. Suppose both the piles settle 120 millimeter, there is no problem. Suppose one pile settles by 10 millimeter, another pile settles by 100 millimeters, differential settlement is 90 millimeter, that is not permitted. So clear, I have given 120 millimeter, 1% of the pile diameter as the permissible total settlement. If all the piles goes down by 120, no problem, one pile goes by 10, another pile goes by 90, both are less than 120, but the difference is about 80 millimeter, that is not acceptable. So in civil engineering practice you should know what is the acceptance criteria. It is there for all behaviors. Crack width, what is the permissible crack width? 0.004 times the cover. The cover is 75 millimeter, you can permit 0.3 mm. The cover is 50 millimeter, you can permit only 0.2 mm. Similarly settlement, what is the total settlement, what is the differential settlement? Similarly the stress levels also. So every case you should know what is the actual stress that is occurring on the structure, what is the acceptable stress or acceptable value, it depends on the material what you are using. Okay, we will see in the next class.